Hello, my name is Gran, and this is my final capstone presentation for Info 4880 Systems Analysis and Design for the fall 2017 semester. This is a quick overview of what I will be talking about today in my presentation. The first part is I will be discussing is my interpretation of a hybrid software development lifecycle, and in here I will briefly go over system development life cycles and explain the models that I contributed to my interpretation of a hybrid model. Then I will show my hybrid model and talk about how it works and how I implement the models. The second part of my presentation will be on a proposal for a virtual robotics lab. In here, I will talk about the robotics lab, how this project was accomplished, and then the roles that I was a part of. Alright, so for the hybrid system development lifecycle, the first thing I did, I had to figure out the goals of creating a hybrid model. To do that, I had to look at an individual called Barry W. Boehm, who was the creator of the spiral model, and according to him, the functions of all software process models, and this includes hybrid models, are to decide the order of the stages involved in the process and to determine the transition criteria for moving from one stage to the next. Boehm believed that software process models are important because they primarily give developers a guide on the order in which the main tasks of a project should be carried out. A software process model also, in the end, needs to answer these two questions I have listed below. What is the next step of each process? And how long should the system continue? This also includes hybrid models as well. I use these questions for answering the hybrid model as well, because a hybrid model is also a traditional system development lifecycle. And also for the hybrid model, it has the challenging task of including all of the positives of each of the combined models, but none of the negatives. And while I did my best to reduce the amount of negatives to nothing for my hybrid model, you may see something that I did not. So with that, now I'm going to be discussing each of the models that I have incorporated into my hybrid model. I incorporated 5 models in total. And the first of these models is the most basic of SDLCs, the waterfall model. It is the most basic of the system development life cycles. It was first cited in 1956 by Bennington and updated in 1970 by Winston Royce. And this model overall set the foundation for defining requirements and analyses in system development life cycles. And here is this is the waterfall model, and it is made up of 6 phases. The model begins with the requirements gathering phase, where all the requirements are collected and detailed out. Then it goes down to the system design phase, where the requirements collected from the previous phase are analyzed to produce a system design which helps in determining hardware requirements, system requirements, and the overall architecture of the system. Then it goes down to the implementation phase, in which the system is developed into smaller parts. Then the testing phase, where each part goes through a test of its performance. The deployment phase, in where the product is deployed to the public. And then finally the maintenance phase, where patches or newer versions of a system are released to address problems with the system or to better enhance the system or product. Each phase of the waterfall model can only begin after the previous phase has been completed and acknowledged to ensure that phases do not overlap each other. Now, these are some advantages of the waterfall model that I try to incorporate into my hybrid model. These advantages are the fact that it is a simple model that is easy to follow and understand. The phases of the model are completed one at a time, and each phase is clearly defined and understandable. When combining these advantages together, the main idea is simplicity. The hybrid model needs to be easy for everyone to understand and to follow. All right, next is the second model that I have integrated into my hybrid model is the spiral model. The spiral model is a modified version of the waterfall model introduced by Barry W. Boehm in 1986, with the philosophy surrounding the spiral model as to start small and think big. So here is the spiral model. It is made up of 4 phases that are passed through multiple iterations called spirals. The first phase that the spiral passes through is the determine objectives phase. This is where project objectives for the current spiral are planned out. Next, it goes to the evaluate alternatives phase, and this is where risks are brought up and are either solved or an alternative method of avoiding this risk is presented. Then it goes to the development and testing phase. And this is where the building of the project is done based on the current objective of the spiral and is tested. The last phase is the plan next iteration phase. And this is where the next part of the spiral is planned out. Feedback from clients can help determine where to go for the next spiral. And at the very end is the project is deployed. So what I mean is at the very end of the spiral, that's the last phase, and that's where it's done. The baseline spiral or first spiral is usually where the planning of the project is the main objective, with subsequent spirals accomplishing parts of the project. The advantages of the spiral model that I have integrated into my hybrid model includes the ability to see the system early on, the fact that project development can be split up into smaller pieces, and the ability to achieve the highest risk management value since you can develop the riskier parts earlier on in the cycle instead of at the very end. When combining these advantages together, the main idea is flexibility. The hybrid model needs to have the ability to change without it affecting other parts of the system in a drastic way. The third model that I have integrated into the hybrid model is RAD, or Rapid Application Development. It is different from traditional system development lifecycle models. Developed by James Martin in 1991, rapid application development is based more on rapid prototyping instead of major planning and recognition of objectives and requirements in traditional SDLC models. Here is an illustration of RAD. RAD is unique in which there are many ways that it can be represented. This particular representation model, I have gotten from a really good source to explain what RAD is. And I apologize for the cutoff block on the left, but it says initial investigation, and that's where it begins. In the initial investigation phase, this is where the project and its goals are discussed with evaluators, clients, customers, etc. And once the project begins, when both the team members and the clients agree to what the project needs to accomplish, It then enters the prototype development phase, represented by the circle of arrows. It is here where the requirements of the prototype are defined, designed out, and then developed and tested to ensure that the system is in a functional state for the client. This process can be repeated over and over again continuously with the client's approval to either create additions, improvements, or something completely new if the created prototype does not work out. Once a project has been developed that meets the client's approval, it then enters the last two phases, where it is implemented to the client and then maintained with additions or changes based on the client's request. Now some advantages of rapid application development that I have integrated into my hybrid model includes, first, the encouragement of customer feedback. This can happen whenever in the cycle, but preferably at the end of each phase of each lap of the development phase. Next is that development time is shorter compared to traditional SDLC models. And last, it only takes a few people to get a task accomplished in a short time frame. When combining these advantages together, the main idea is multitasking. The hybrid model needs to have the ability to allow multiple people working on different tasks at a consistently fast pace. The fourth model that I have integrated into my hybrid model is Agile. Agile, just like the waterfall model being an iteration of, just like the spiral model being an iteration of waterfall, Agile is an iteration of RAD. And just like RAD, it is focused on creating multiple prototypes, then working on a singular step-down approach in the waterfall model. Now, what makes Agile an iteration of RAD is on how much the project cycle is repeated again. So this is an illustration of Agile. Again, there are many other iterations of this model out there. The main difference between the two graphs is that the project prototypes are sent at the end to the client for them to use and test out. So it goes through the initial investigation, it goes through the development cycle as before, just like RAD, but instead of deploying a final just a final product to the client and that's the end, you can implement a prototype to the client and they can use that in a live testing environment. When changes or implementations must be made, then the Agile cycle goes back to the beginning, and the main goal is to either produce the next prototype to deploy to the client or the final product. And that is represented by that arrow that runs along the top that says 2 to 3 months later. That's the one I used. That's the one I used. You can use whatever you want. It just depends on what you and the client agree on. Now, just advantages of Agile that I would like to integrate into my hybrid model includes being able to evaluate each iteration of the project instead of only the final product at the end. And full prototypes of products can be developed and implemented for a client before the next phase of the project can begin. When combining these advantages together, the main idea is easy testing. The hybrid model needs to be able to test the product or software as easily and efficiently as possible. Agile does that by having working prototypes in action, and when a need for improvement is detected, then the product goes through the entire Agile process again. And now the final model that I have integrated into my hybrid model is some form of object-oriented analysis and design. It first took shape from an introductory approach of a new programming approach back in 1960. and the idea of analysis and design methods were implemented in the 1990s. Object-oriented analysis is based on describing software engineering requirements and creating software specifications. Object-oriented design implements the theoretical model created during the analysis phase. Developed in the 1990s by Grady Booch, the unified modeling language tried to set a standard for models, notations, and diagrams that are associated with object-oriented analysis and design. And that is what I have represented here. This is an illustration of a UML diagram. Now, each object in this diagram is represented by a shape with lines connecting the pathway from one shape to the next in the cycle. So for example, like the one I have here, the diamond on the left signifies the start of the model, stating the overall goal of the project. And then the split up after the diamond represents the team working on the project, splitting up into two groups to get two tasks done at the same time. Tasks are represented as blue ovals, with the white ovals representing subtasks or tasks within a task. And this is just one way of how many possible ways that UML models can be created. You are not limited to this much. These models can be as little or as big as you want, depending on the project, of course. Some advantages of UML that I have integrated into my hybrid model includes the ability to easily upgrade the project from small to big or from big to small. The fact that it provides a clear map of how to proceed through the system, and well, that's what happens when you combine the advantages together. The main idea is creating a clear map of how to proceed through the hybrid cycle with the capability to adjust the size of the cycle if needed. So, after looking at these 5 models and what their advantages are, what did I come up with when combining all 5 into a hybrid model? Well, I came up with this 2-part model in the end. This is my final hybrid system development lifecycle that I have created. I'll give you some time to take a quick look at it, but if you're questioned about it in any way, don't worry. I'm going to go over it next in the next couple slides. All right. So as I stated before, the hybrid model that I created is split up into 2 parts. This is the overall model, the main model, that everyone in the group working on a project will look at. The way that this model flows begins at the black diamond on the left, where the main goal of the project is placed, much like the UML diagram. And then once the goal is determined, then the group working on the project will divide into multiple teams, and each team will begin work on their individual goals of the phase. So everyone has split up, so we'll say that once everyone knows what they're doing, they'll split up into 5 teams. Each team will work on a different goal. At the end of every phase, the team meets up together, which is represented by that long gray rectangular block, to discuss their progress and what to accomplish for the next phase. After that, then everyone moves on to the next phase and their next goals. And taking a page from the waterfall model, every team must move on to the next phase together. No one gets left behind. Doing that will risk some to everyone of losing track of what is going on in the project. And full teams can even work with another full team, as indicated with the red dashed lines. For a complete phase, if the goals of one team are similar or in line with another, and doing the work together would be the best feasible option. So let's say, I have about 3 examples of that. Well, 2 different types. So let's say Team 1 gets their goal accomplished, but they were discussing with Team 2, and they realized, hey, our goals are 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 similar. Let's work together. Well, perfect. So Team 1 will go work with Team 2, while on the diagram, you would just either cross out or block out the Team 1's second goal rectangle to show that Team 1 and Team 2 are working on the second phase together. You can have like 3 teams working on a phase, so like Team 4 and Team 5 at the bottom. They could, at the end of the second phase, they decide, hey, let's go work. Team 3 needs our help because our goals somehow align. It'd be better if we all work together. Both teams can go work for Team 3 as long as they cross out their goal blocks underneath. So something I have to keep updating. And how many teams are created just depends on the overall number of people working on the project, and the number of phases the model goes through. It depends on the length of the project. It's totally customizable. It can be as little or as big as you want. This overall model provides a simple and clear way of everyone seeing what each team is currently doing. It combines the structure and organization of the waterfall model. It's all laid out with UML, and includes the multitasking capabilities and possible short development times of RAD and Agile development, if you decide to only work in 2 phases, or 1 phase, or 3, like I have here. Now this is the second part of my model, the detailed model. And this is supposed to represent a zoomed in close-up view of one of the blue rectangular team goal blocks from the overall model that I showed previously. The detailed model that I have here contains the process that each team goes through to accomplish their goals for the phase of the project. This is based on the flexibility of the spiral model and easy capabilities of RAD and Agile development for testing prototypes. It begins at the top with defining the objective that the team would like to accomplish for the phase. Next is to identify any risks that may come up developing the goal, the objective, and how they can be resolved. Then you design the objective of the phase and to develop a prototype of the objective out of that design. And then finally, the goal goes through some form of test to ensure that it is a satisfactory build. Taking advantage of RAD, and if time permits, this cycle can repeat itself multiple times until it is time to share your work with everyone that is working on the overall project. Which at that point, you stop wherever you are. Just keep going. Doesn't matter if you're in the middle, whatever. Show what work you have when you meet up with the entire team. Stop whenever it's time to meet up. Don't waste time. That's what I'm trying to convey here. So that is my iteration of a hybrid system development lifecycle. Despite what is shown here, there are numerous ways that a hybrid model can be created, either with a combination of the models used within this paper or using other system development lifecycle models that were not discussed. If you have any questions for this part of my presentation, you can look at my accompanying research paper, my ACM paper. Now we are going to go on to the second part of my capstone presentation, which is the virtual robotics lab. First off, what is it? Well, this is a background on this lab. First off, research into robotics has helped advance every aspect of modern technology. The concept of robots may be familiar to our culture. It's not common to interact with advanced robots that would collaborate with humans. In other words, we can have robots work together with us. There may be programs that interact with humans, but it doesn't compare to cooperating with a robot to accomplish a task. And this leads us to the National Robotics Initiative 2.0, Ubiquitous Collaborative Robots. The NRI 2.0 program has been exploring the innovative concept of robots completing daily tasks in replacement of humans. The concept of collaborative robots, or co-robots, furthering their knowledge of everyday life to assist humans with work productivity, can be explored through further research. The only way to move toward this next step in robotics knowledge is with the human interaction with the robots. And that is where we're at right now. Individual interaction between a single robot and a single human has already been achieved. The current goal is to study the interaction of multiple robots with multiple human beings. In order to run these kind of tests and simulations, numerous plans must be put into place to ensure the safety of the users, along with the clear instructions on how and when to interact with the robots. This includes the following bullet points. First, safety features need to be in place to make sure the virtual robotics lab is secure, along with the data stored within the facility. Next, a proper log of the data that is required for use of the robots in the virtual lab should be assembled to track numerous kinds of data. A way for lab users to interact with one another about robotics information is required to further communication between one another. And every company and laboratory must have a website to help with the access of robots in the virtual lab, along with other features. So the main goal of this virtual robotics lab that our Capstone class are working towards is to have a secure virtual lab that can keep track of users and what they do. This lab should also provide the means to collaborate with groups through numerous programs. In order to create this virtual lab, the Capstone class that I am in were in charge of creating a proposal of how to construct this virtual lab. And this is made up of 5 teams. First is the project management team, and their responsibilities are to produce a project management plan, coordinate the other teams, and produce the final project proposal. Next is the social media team, and this team is responsible to support group collaborations, comments, and advertisements to help fund and grow the virtual lab. Basically, create social media outlets that will accomplish these tasks. Third is the security team, and their job is to create a security plan that handles electronic and physical authentication and other important security features. The fourth team is the web development and server team. Their job is to develop a web page that requests the use of the virtual lab. And last is the database team. They are to create a database that has tables that will track registered users of the lab and other important criteria. The parts that are bold and highlighted in yellow are teams that I am a part of, and we'll be talking more about. The other teams, while important, I have not really been a part of, so I will not be discussing anything about what they did in this presentation. For the project management team that I am on, I can say as of the date of this presentation that we do have a template that we are currently using to create the proposal. We are just waiting for the other teams to submit to us what they have so we can then implement it into the final project proposal. So I won't be discussing too much on project management. Mostly we were just looking at the background of the NRI and why we are building this virtual robotics lab. The stuff that I talked about in the previous slides. What I can discuss in detail is the social media aspect. So, as being a part of the social media team, we have created a lot of online social media accounts to go along with this virtual lab. First, we have created a Gmail account that will be connected to all social media accounts associated with the virtual lab. The Google account associated with this Gmail account will also be tied to a YouTube channel, which will post videos and advertisements about the virtual lab and its research. Next, we have created a private Reddit group which will be used for communication and collaborations between lab users. And finally, we have created a Facebook page, which will be made public to allow the promotion of special events, announcements, posting of videos, and support for advertising, to name a few features. This Facebook account is currently under the ownership of Rob Labman, a fake name, but can be changed in the future once this proposal is handed off to the individuals who are going to work on constructing the lab. All of the usernames, passwords, and links that you have seen here in these two slides can be used to access the associated services. More information about our social media component can be viewed in the proposal of the virtual lab. So the last thing that I would like to mention is, for the creation of this virtual lab, it could be done with the hybrid model that I created. The project goal will be the lab, then each of the teams will go into one of the rows, and then by going through the RAD and Agile process in each goal square, a group who would take our proposal could create this virtual lab with this hybrid model. There were even moments while the other teams in our Capstone class working on this would work with other teams to help accomplish a similar goal. An example that I was a part of was the social media team and the web team meeting up together to assist each other in creating the social media accounts and how to incorporate the sites into the website proposal, which can be represented by that dashed red line. It just shows that a hybrid model like this could possibly work. With that said, that is the end of my final Capstone presentation. Thank you for listening, and if there are any questions, please refer to either my research paper for my hybrid model or our final project proposal for questions about the virtual robotics lab. Again, thank you for listening.